Hi guys! Welcome back to my channel. In this video, we will be enumerating and introducing the different measures of variation. Without further ado, let's get this lesson started. Measure of variation is otherwise known as the measure of variability or measure of dispersion. From the word itself, dispersed, it describes how scattered or clustered the data are around the mean. If the measures of central tendency gives us an idea to where the middlemost data lies, this measure of variation gives us the idea of how scattered or clustered the actual data are around the mean. Are they clustered closely around the mean or are they scattered far away from the mean? To interpret the different measures of variation, if we have a small measure of variation, it means that the data are clustered around the mean and that is ideal. However, if we have large measures of variation, it just means that the data are scattered away from the mean. Again, if we have small value of measures of variation, it means that the data are lying closely around the mean. If we have a large value, it means that the data are far away from the mean. We actually have three measures of variation. We have the range, variance, and standard deviation. In this video, we will just be introducing these three, but their in-depth discussion will be the content of the other videos for this series. So first, we have range. It is signified or symbolized by the capital letter R. And it is the simplest to compute. I think I have mentioned this while we are doing the frequency distribution table. We have a step there that involves us to compute for the range. It is also non-parametric. When we say non-parametric, it does not involve any measure of central tendency. For this range, we are not concerned with the value of the mean or the median or the mode, and it is easily influenced by outliers. To better understand this, I suggest you watch the next video because there we will be discussing the range. Next, we have the variance. It is symbolized by small letter sigma squared, that is for population, and small letter s squared for sample. Here, the symbols are case sensitive, meaning they should be both small letters. Variance is the average of the square distance of each datum from the mean. So what we're going to do here is we will get the distances of the data from the mean, square those distances, and then get the average of those square distances. So again, we will have a separate video for the computation of the variance. It is parametric because in variance, we are involved with the mean. Lastly, we have standard deviation. It is symbolized by small letter sigma and small letter s for population and sample respectively. So if you may notice, variance and standard deviation in terms of symbol are quite similar because the standard deviation has an exponent of 1. For variance, we have an exponent of 2. So again, we will also have a separate video for the computation of the standard deviation, and it indicates how closely each of the data is clustered around or scattered from the mean. Just like variance, because it involves the mean, it is parametric. Again, when we say parametric, we are dealing with the different measures of the population or the sample. Meaning, to compute for parametric measures like standard deviation and variance, we need to know the mean, the median or the mode, or any parametric measures to describe the population or the sample. For the range, it is not parametric because computing the range does not require us to know the mean. So that's it for the introduction of the different measures of variation. In the next videos, we will be discussing how to actually solve these measures of variation for grouped and ungrouped data. Thank you for watching and see you on the next video.